way, you could pull it up, you don't necessarily have to pull it up and walk down, you can just go the normal way, you're done taking it. But just make sure, practice with whatever calculator you plan to use on the real test. So if you're refusing to get your own or check one out for free from the bookstore, then you have to use this one, which is not my favorite. So, FYI. All right, we have a map of Nelson County is laid out in the standard XY coordinate plane below, where the center of the county is at 0, 0, a cell phone tower is at 5, 4, and Esteban's house is at 10, -2. Each coordinate unit represents 1 mile. The tower signal range is 10 miles in all directions. That's the same question for a few of those, or the same setup for a few of the questions. For 15, we want to know the strength of the tower signal to Esteban's house depends on the straight line distance between his house and the tower. What is the straight line distance in miles between Esteban's house and the tower? Okay. So here's what you would have to do. Because you could draw a straight line, but you would need, there's a few ways you could solve it actually. I don't know that you guys have the distance formula memorized. I don't know if that even rings a bell to you. So what might be a good strategy is to make a triangle out of this. So and then the straight line from the Esteban's house to the cell phone tower would be what we call the hypotenuse. I feel like that might be easier than memorizing the distance formula. So hypotenuse is like the longest side of a right triangle. What's needed in a right triangle? And by making this like these straight lines, that makes a 90-degree angle here. So if I can figure out what the distance is from top to bottom, so what's that distance?
That's
1, 2, 3, 4, 5, 6. Right? Everyone do that? 6 units. 1, 4, 5, 6. And then the base is 1, 2, 3, 4, 5. What could I use to figure out my hypotenuse? Anyone know? Pythagorean theorem. Not something we really talk about in Algebra 1, 2 ever, but it's something that this test, they expect you to know things from prior years. But again, it's helpful that we're going through this because now you can kind of refresh your memory. So what is Pythagorean theorem? The formula. A squared plus B squared equals C squared, where C is the hypotenuse. So that's what we're solving for. We don't know what the C is. A and B can be the sides, it doesn't really matter which is which. So we have 6 squared plus 5 squared. Usually anytime you plug stuff in, I tell you to use parentheses, it's good practice. What is 6 squared? What is 5 squared? And that's equal to C squared with 36 plus 25. Plus 25 is 61. And I use a calculator for that. Don't do that. All right, so then I do this. Is the C by itself? No. It is not by itself. So we have to do the opposite of what's being done to isolate it. What's the opposite of squaring something? To take the square root. And whatever you do on one side, you have to do to the other side of the game. So now the C is alone because squaring something and taking the square root cancels each other out. Is alone. The left side matches one of the answers. Was the correct answer supposed to be E? Yeah, it should be, hopefully. It's P. Yes. Okay, so use what you do know to problem solve. Questions from anywhere else in the text? Chris? Number 6. Okay, so this one, Ryan and Tomas walked to school and then to the park as described below. Ryan walked 2.3 miles from his home to meet Tomas at school. It doesn't really look like Tomas, so I'm gonna. Tomas walked 2.7 miles from his home to meet Ryan at school. Once they were at school, the boys walked X miles to the park and then X miles back to the school. The sum of the distance Ryan walked and the distance Tomas walked was at least, and underline that because that was significant compared to what's down here, was at least 15 miles, but not more than 21. One of the following is a graph of the possible values of X. Which one? Okay, so hang on. So what was the right answer for this? It was A.
Yeah.
Sum of the distance they each walk. Possibly. Hold on. Understood. It does say that it's A. Let me see if I can remind myself why it's A. Okay, so number 6. Okay, so here's Ryan's distance. It was 2.3 plus the distance from the school to the park and then back. Right? Let me reread this. Yeah, because they walked to the school, they walked X miles to the park, and then X miles back to the school. So that's why it's there twice. And then Tomas walked 2.7 miles to the school, then again to the park and back. So that's why it's there twice. So we had to make an expression for that. So here it is expanded. 2.3 plus 2.7 is what? It is 5. Feel free to use a calculator for that part. And then what is X plus X plus X plus X? It is not.
3x.
4x is correct. Yes, and I have it written right here. X plus X plus X plus X. So everyone see how this is the distance Ryan walked and then Tomas walked, and then they wanted you to add them together. That's what sum means. That's what we just did. Is it about this, Adelie? No. Okay. Okay, so that's what it is. And then it gives you some, what do you call it? Signal words that would imply that we use inequalities. So let me go back to where the answer is not showing. Can you guys stop with the random mumbling? Thanks. So 5 plus 4x is what we agreed on is their distance added together. And then you have to use these signal words. So if it's at least 15 miles, can it be greater than 15?
No. Yes.
Can it be exactly 15?
Yeah.
Yes, I'm gonna put a little line there. I probably should have wrote that on the other side, but it's fine. I'll put it over here. And then, but not more than 21 miles. So does that mean this can be greater than 21? Can it be less than 21? Can it be exactly 21 if it's not more than? So we're gonna put that little line there. The little line doesn't really help us that much this time because all of them are closed circles. So it doesn't eliminate any there. Now you actually have to solve for X in both situations to see what X can be. So when you're isolating X, you always start with what is Before, well, yes, but then. How do you know what to get rid of first, like the 5 or the 4 in this situation? Not the 4. So listen, anytime you solve for x, start with what is farthest, so the 5. How do you make the 5 go away? No. Subtracting it would make it go away. Whatever you do on one side of the symbol. Okay, good. So I get 4x greater than or equal to, stop that noise. 15 minus 5, which is opposite of multiplying by 4 is, do that on each side. Do I need to flip the sign for that? No, because I did not divide by a negative, so leave it alone. Sign stays the same. What's 10 divided by 4? Always clear your calculator before you use it. 10 division sign 4 equals 2.5. So I need one where it looks like the circle's on 2.5-ish. So I can eliminate B, I can eliminate C, I can eliminate D, and I can eliminate E. Just from that part. But if I continue to solve same steps, subtract 5 on each side, I get 4x less than or equal to 15, I think, right? Yes, and then divide 4 on each side. And then you need it where the other dot is on the 4, which it is. And x being in between these two numbers should be in the middle, not like on each. Okay, it's an and, not an or. So questions on this one? All right, questions on others? Tyson? Number 10. So hopefully if you've been getting these wrong and you're required to correct it, that you've been taking notes down. All right, this one's a good one. I can see why it's confusing. So a pattern exists among the unit's digits. Stop talking. A pattern exists among the unit's digits of the powers of 7. Note down here, it explains what a unit's digit is. But I've never heard about that before either. The unit's digit of 2,401 is 1. So what are they referring to when they say unit's digit? No. When they say there's a pattern between the unit's digit, where are they telling you to look at the number? Okay, guys, this is the key right here. Look at this only. The unit's digit of 2,401 is 1. So what's the unit's digit of this number? This number right here, that underline. 1. What's the unit's digit of this number? 7. What's the unit's digit of this number? 9. What's the unit's digit of this number? 3. What's the unit's digit of this number? 1. Are we seeing it now, what they mean by unit's digit? They mean the last number. So they're saying there's a pattern in all the last numbers for the powers of 7. It goes 1, 7, 9, 3. 1, 7, 9, 3. 1, what would be the next one? The next one. The next one. And they're asking you for 7 to the power of 50. So you have a few options. You could keep this pattern going until you get to 7 to the power of 50. What I would do is, since they stopped giving me numbers at this one, by the way, this would not fit in your calculator. There's no way you would tell. That's why this is a good question. We're not leaving until we get this done, so you just stop talking. Gavin. All right, so since the last number that they give me is for 7 to the power of 8, and they want 7 to the power of 50, well, what's 50 minus 8? 42. How many different numbers are there in this pattern? So I'm gonna figure out what 42 divided by 4 is. I don't think it's an even number. So let me see. 42 division times 4. I get 10.5. So that means I go through 10.5 rotations of the same 4 numbers. So since we ended on this one, and then I go like half a rotation, that means that the answer is gonna be 9. Because I went through 10.5 rotations of the same 4 numbers ending at 1. So then the next number would be 7, the next number would be 9, that's half a rotation. So the answer is 9. So we never like teach that, but it's a problem solving. This test is more about problem solving. If I can trust you to not lose your paper, then you can hang on to it. If you can't be trusted to not lose your paper, then go put it in the bin so that you don't have to start over. These are tests. Do not lose your paper. I guess start all over. Actually, W, make sure you clear.